Welcome, and this is the first in the series of videos going through your packs. So the idea of these videos is that they sit alongside your lessons, so that if you miss a lesson for any reason, or if you want some additional help going through some of the bits of the topic, or for any reason we're not able to do lessons in college, so we've had to go back to remote learning for any reason. So what you're going to need is a pen, a calculator, and a copy of your notes. So you should have this. This is your pack, and this is the first one. It says pre-coursework atomic structure on it. So this is the pack you're going to need. And you'll see in the description to the videos page numbers. So each video will take you through a set number of pages. Okay, so all the packs are laid out in the same manner. So on the front cover, we've got the title of the pack, and we've also got the spec statements. So basically, by the end of this particular topic, these are all the things that you're expected to be able to do and to know about. So one good way of checking is to go through each of those syllabus statements at the end and tick them off if you're happy with them. If you're not happy with them, if you're struggling with any of them, you can either re-watch the video on that particular topic section again, look at the PowerPoint again, or come and ask one of your teachers about that particular bit of the topic that you're struggling with. So the first task is to learn the symbols of the first 30 elements, and there will be a test on tasks 1 to 5 in the first week of term. So what you're expected to be able to do is, if I give you the name, you can give me the symbol and vice versa, and you have to do that for the first 30 elements. It's really important that you're able to do that. You'll always be given a periodic table, so you don't need to worry about any of the numbers, but it is helpful if you know, for example, that potassium has the symbol K and phosphorus has the symbol P. Okay, so as well as learning the names and symbols of the first 30 elements, you also need to learn the names and the formulas for some common compounds and gases. You'll see here we've got acids. So we've got common acids that you should already be familiar with, but you need to know the formulas of each of those. Also the same with the common alkalis, gases, and elements which are diatomic. So you need to know hydrogen, for example, is H2, not just H. Argon, on the other hand, is just Ar. Task 3, you're expected to learn the formula of your ions. So these are just the common ions. Again, they are things you should be familiar with. So you should know that everything in group 1 has a 1+ charge, everything in group 2 has a 2+ charge. You should also know that this group here with oxygen is -2, and the halogens are always, or usually always, -1. So the common charge on them is -1. There are a couple which you need to be familiar with. Aluminium is +3. There are some here in what we call the transition metal elements, or the D block elements, which have variable oxidation states and variable charges. So iron tends to come in two main forms, iron 2+ and iron 3+. Copper is 1+ or 2+. Ag is the symbol for silver, and it's one you need to know, and it has a 1+ charge. Zinc has a 2+ charge. So we can tell which one of those variable oxidation states we're dealing with by looking at the Roman numerals after the name of the metal. So iron with the Roman numeral 2 is Fe2+, and iron with the Roman numeral 3 after it is Fe3+. Manganese with a 2 is Mn2+, and chromium 3 is Cr3+. So if we've got a metal with a variable oxidation state, which we quite often do, we need to say which one we're talking about, and we do that by adding the Roman numeral after the name of the metal. Not only are you expected to know that, you're also expected to be able to work out the polyatomic ions. There are some common ones which you're going to have to learn. So sulfate, for example, you need to know is SO4 2-, carbonate CO3 2-, and hydrogen carbonate HCO3-. Most of those should be familiar to you. There may be a few ones like the ammonium ion NH4 positive, the chromate CrO4 2-, the dichromate Cr2O7 2-, which is new to you, but they're not too many, but you do need to learn them. So on page 5 of your notes, there's just some practice. So what I would suggest you do is you have a go at learning the first couple of tasks, and when you've done that, you use this as a revision page. So how many can you get right without looking back at your notes? Then have a look back, check the ones that you haven't managed to learn, and relearn them. Another good way of learning these would be to do them out on flashcards. So you'd have the name on one side, the symbol and the charge on the other side, and can you, if you're giving the name, give the symbol and the charge, and if you're giving the symbol and the charge, give the name. This is a good way of learning them. So the reason we do all of this, the reason why we make you learn all these ions, is so that you can put them together to make formulae. At A level, we no longer write any word equations, so all equations need to be written using symbols. So it's very important that you get comfortable using these earlier on. Okay? So, things to think about. Your compounds are always neutral, so you never have a charge on the overall compound. It's made up of these ions, and the ions are adding in the ratio which makes them overall neutral. So for example, Fe2+ has a 2+ charge. OH negative has a 1- charge. So I need 2 of these to balance out, because 2+ minus 1 minus another 1 will give me 0. So if I think about the next one, silver nitrate. I have silver, Ag positive, and I have NO3-, that's nitrate. So I've got 1 positive and 1 negative, so I need 1 of each, and I get AgNO3. Next one, magnesium chloride. Magnesium, Mg, 2+, chloride, 1-. Well, I've got more positives than I've got negatives, so I need 2 of these negatives to cancel out this 2 positive. So I'm going to need 1 positive ion, but I'm going to need 2 negative ions. So the formula is MgCl2. Notice I don't need a bracket because it's not a polyatomic ion. Okay. Last one we're going to have a go at doing. Copper. Well, copper has 2 oxidation states, +1 and +2. I know I'm dealing with a +2 in this case because of this Roman numeral. So I have Cu2+, I have an oxygen, the oxide ion is always 2-. So again, those charges will cancel, so I need 1 of each, and the formula is CuO. So you pause the video now and have a go at the rest of them. So there we have the completed table. So you can check those off against yours and make sure you've got the right things. So do be careful where you use brackets. So for example here, I do need a bracket because I've got 3 of these OH ions. So if I don't have the bracket there, it gives me the wrong formula because it would be FeOH3, which is not the same as Fe with 3 OHs. Where there's only one of them, I don't need a bracket, and if it's not a polyatomic ion, I don't need a bracket either. So here, for example, I've got 2 hydrogen ions, so it's just H2SO4. From now on, you do need to be very clear about the technical terms that you're using. These are ions, they are not atoms. These are compounds. You need to know the difference between them, and you need to use the right technical term. So a chloride ion is very different from a chlorine atom or a chlorine molecule. They all have a different formula and they all have a different character. So a chloride ion looks like that, a chlorine atom is that, and a chlorine molecule is that? And you need to be very clear when you're talking about those different species. So that finishes this first section of your notes. So what you need to do now is just check back over, check with the spec statements on the front page and make sure you're happy with everything we've covered in this video. There are other videos you can watch as well, and the links to them are in your packs. So do have a look at those, especially if you're struggling with making compounds from the ions. So until the next video, take care, stay safe, bye bye.